of the topic. And I think my home internet is quite, I mean, it's not stable. I think I will not enable webcam. Is it okay for everyone? Like, hello?
Yes, I think it's okay.
Okay. I think everyone are here already, right? We can start now, right?
Yes.
Okay. So I will share you my screen. Can you see my screen, Sherry?
Yes.
Yes, sir. Yes.
Okay, that's good. Okay. So I will enable it first. Okay. So this week, as mentioned by your lecturer, like we will have at about 4 weeks, you will meet with me, and the first week we will see on recursive function, and the following weeks we have some other topics like pointer and sorting algorithm, and we will see it together later. And today's topic is about recursive function. I think most of you probably already heard about a topic in programming like function. You have already learned like basics concepts like variable, loops, for loop, while loops, function array, and some other topics. And this is just an addition to the functions. This is called recursive. Is everyone like using what tool do you use for coding? Can anyone confirm like the tool that you use for coding in the lab? For example, you use Visual Code, Code Block, or some other code editor.
We use Dev C++, Mr.
You use C++. I mean
Dev
the
C.
tool use Del C, right? Okay.
Yes, Dev C++.
Okay, that's good. It's okay. Like in our class, we use a code block, but it's similar. It's the same actually, just a different UI. But the way we write the code is the same way. Okay. So next, I can go next to the next slide. Okay, sorry for the notification. I think let me close it first. Okay. And here is the outline of the class today. And actually, the class is about 2 hours. Anyway, we will have a short breaks in between so that everyone can have breaks. Otherwise, we experience that we cannot catch everything during the class for this 2 hours. It's hard to follow up, for example, when we are online. So we will have a breaks in between maybe at 10:30. After 1 hour, we'll have a short break, about 5 or 10 minutes, and then we come back. And this is the outline of the class today. We will cover 4 main topics. It's actually a part of recursive. But the first point, we will review some part of the function. I think everyone already learned about this function. And next, we will jump into introduction to the recursive. What is it and how it can be used, and how can we implement using coding. And in the lecture, normally in my class, we introduce the students using pseudo codes. It's just some part of the algorithm techniques that illustrate or explain them how to coding. And next, we apply the language. For example, in this semester, we use C++. And I think everyone already learned about the C programming, which is a very basic language. And in C++, it's just an extension. I think it's okay for everyone. And last but not least, we will have Along the lecture, we will see example and as well as the practice together. Like I may share you my screen and we can coding together. So during the lecture, like everyone, you can take notes. If you have notebooks, okay, you can write it down there. It's good to have a notebook next to you. Like we can either it's too much or some part of the lecture, you can note it down. At least you can get something from it. And it's okay to no need to write everything from the slide. We share you the lecture letter. It's okay. You can just note some part that are quite important, and then you should note it down. All right, so we will start to the first topic. Before that, I may use some of my background. I finished my bachelor in computer science at the place where I currently working on at ITC. I finished at 2016. And next, I pursue my 2 years master degree in Thailand in the field of software engineering. And in the school, like it's called SIIT. It is an international institute. Like there's I also have some Indonesian friends there. Like some of them they're doing a master and some doing PhD program. Okay. And it is a part of Thammasat University in Thailand. Okay. And after I graduated from my master program, I come and teach at my institute starting from 2018 until now. And also being a part-time lecturer at another institute called NIPTech. Okay. In talking about my experience, I involved some several projects at school. Actually, I don't work at the outside companies because after I finished my master program, I jump back into the academic education at my institute. So we also have some several projects related to LMS system called learning management. It is based on Moodle, like we use Moodle. It is a widely used tool that we can use we can set up on our server. We can start to customize and we can upload course materials. It allows us to manage students, and teachers can assign quiz, assign tests, and in the system will auto scoring, for example. And lately also we have also e-learning system. It is also a part of LMS, and we also design, we also build an online exam system. During this COVID period, it's hard to for everyone. For example, the new students, they take entrance tests. So at school, we prepare an online exam system that allow everyone can take the test online. Okay. And beside of this, I also supervise our bachelor students on the thesis work, which means that during our program, we have 2 times of internship. The first one, like in before final year, they go to the company, they are doing internship, work on some topics, and they discuss with advisor or supervisor at school, like whether the topic is okay, how is the work, or some other problem that they can discuss. Okay. And most of the students, they work on website development, web application development, mobile application, and so on. Some of them are like they take experience from the internship a lot. Okay. I think that's it. So I will not talk too much on this. This is just the background of my myself. Okay. We can go next to our lecture. So the first part is about the review on function, and we will see all together. I think it's quite repetition for some of you, but I think it's important, like when we learn about recursive function, it is good to understand first everything clear about the function. So I think we will take this time to explain a little bit here, like function. What is function actually? As you have learned like before, a function is a part of code, like a piece of code that you combine them into a specific name, right? You give a function a name, and then you put some codes inside we call it body of function. And once the function is created, you can call it many times. That is a basic of the function. And normally, when you design your function, the function can return value. Okay, you either create with a returning value or not. It's okay, depending on you. Okay. And why do we use function? Normally, a large program like we can divide into the smaller one so that we can easy to implement and also easy to debug codes. Because most of the time we are working in how to find errors in the program, why it caused the program to crash, or sometimes the result is not what we want. That's the thing, like important part of the program. We should divide into smaller parts, which is called function in here. In many other point, like the code can be reused. You can call it many times. Once you define, you can call it as many times as you like. Okay. When needed, you can call it. Just give it a name. Just call it using the name and the parameter that it takes. Okay. I think everyone clear about this already. Like we just reviewed it again. And you may have seen before, like we have two types of function. There's two main type of function, either in C or you learn C++, Java, or some other programming language. Normally, they have two main types of functions. The first one we call a standard library function. It is called a built-in function. So I also mention it here. There are some terms that can be changed. You can call it built-in function. It is a standard library or existing function. Okay, that means that function is already defined. When you install the tool and you install compiler, the existing function is already coming with. You can just include it, right? As you have seen before, like you have the math library in C language, you have stdio, so that you can use some certain function like printf or scanf in C programming, right? Because in C, if you don't put the library in the header of the codes, like include stdio, you cannot use printf or scanf and the program will not run. Okay. And some other function which exists in the math library, you cannot use that is inside this library, this one, math.h. So actually these are called standard library, or we call it built-in function. And another type of function is called user-defined function, which is a function that is defined by the programmer. Like we are the one who write codes. We can customize, we can write our own function to perform a certain task in addition to the existing function. Okay. So this is what we are focusing on. We already create some function. I think you have to learn. You learned before, and what we are focusing here is user-defined function, and you can enable it as a recursive one. Okay. And this is some just give you an recall on the syntax in C language, how we can create a function with a returning value. Okay. This is the structure, right? The first one is called the type of the function. Sometimes you can say it integer, int, float, character, or string, or something. Sometimes you call it void, right? void. Okay. That is the function with no returning value. We use void. Okay. And it has the function name, the name of the function. You give it a name, and inside this function, you provide a piece of code, right? This is the code, like you may have multiple lines, or some other function can also be called inside the body of the function. Okay, and that's it. And also we need a parameter. Okay, whether you design, when you create a function, you want this function to have certain parameter or not. If you don't need a parameter, you just leave it empty. If you need some parameter, you can just declare it there. Okay, just declare that to inform that okay, this function needs one parameter. It is an integer number. Okay, you can specify in a parameter name there. Okay. Normally, the parameter give us an ability to take some input from outside to be used in the body of the function. If we don't take it as parameter, we cannot use that value. But actually, it can use if we declare that variable as global. Perhaps you already learned before local and global variable. Have you learned about the global and local variable before? Could you confirm? It's okay, just say yes or no, it's fine. Hello everyone.
Hello, Mr.
Yes,
Okay. Okay.
I think I've ever learned that global
All
one.
right. Okay. This is called the local and global, like something like here, local and global variable. Okay. It's okay if you haven't seen it before. We also seen it in some part of this lecture. This is just called the scope of variable. Okay, we can call another thing is scope of variable. Okay. So inside a function, if we don't take a parameter, it is empty, but we still be able to use a certain variable if that variable is declared as global. Okay. Normally, if it is global, it is declared outside the main function. When we write C programming, we have a main, right? The structure of C programming is something like we have I may type something here. You may have includes stdio or something, and then you have main, right? Sometimes main you say integer in preceding. This is the structure of C programming, and you write some code here. Okay. So when you say global variable, it's something that you declare outside main function here. If you say integer and here, okay, and here is defined as global variable. Okay, this is global variable, a variable that is created inside outside the main function. Okay, if you create it inside the main function here, it is normally called the local variable. Okay, that is the difference between local and global. This is the scope of variable. Okay. It's okay, just an introduction here. We also see it in we also have a part like we show example how it is defined as global and how it is defined in local variable and how it can be used in the following slide. And this is the structure, and you also see the example on how to create a function here. This is a function, example function. You have the type here. Okay, returning type is integer. This is the name of the function, and you have two parameter here. Okay, integer 1 and integer n2. It's just two numbers that you take as an input to this function. Okay. In this place, okay, you perform some operation in order to find some logic that we need. Okay, so in this case, just sum it together. And finally, we return this. This is basically just a simple function. And for the non-returning value, because function may return value, that means sometimes we can create it to return some value that we want, returning back from function. And sometimes we don't need the returning value. So what we need to do, just to declare it as y here, and there is no returning command inside the body here. Okay, that's it for the returning value. No returning value, for example. And this is show you examples of how we can create two functions. One function is that we allow them to return value, and another function is no returning value. So what is the difference here? The types here are different. Okay, this is the type. There must be different. And inside the returning function, we need a return keyword. If we don't have the return keyword here, the compiler will inform us, okay, there are some syntax error. Your program cannot be compiled and run because something wrong. The grammar is wrong, for example. So we need this. This is the trade-off. Okay, this is the condition. Okay, not a trade-off. The condition that if we need a returning value, we must return something that is the type of this return value, which is in this case integer. Okay, this is integer. What we return here, result or yes here, is also an integer. Okay, it must be the same. Okay, and for the no returning value here, we just declare it as a keyword here. We just say it void. Okay, and we don't need the keyword something like return here, right? So what we can do here, like we display some certain message, or we calculate something, or we modify a global variable. Okay, so we don't need to return it. That is the difference. And how we can execute the function. What we do here, for example, in the C programming language syntax, you have the main, right? In the structure of the program, you have in the header include library, you have the main function. In C or C++, in order to run a program, you must has a main function. Main here is also a function. Okay, it is the first place that the code run when we compile it. After we compile and we execute it, is the place where the program, our program run here. Okay, so if we have our function, we define our function here, we can call it inside main. Okay, what we need is just the name of what is the name of this function. Okay, and if it needs some certain parameter, we just provide it. That's it. That is how we can activate the function. And if you have more than one function, we can call it consequently, okay, based on our order. Sometimes if the function return value, what we need to do when we call it, we need to assign some variable, right? Because if this function return a value, how this value can be stored, which place this value return to. So this, in this case, we return it to this variable. Okay, because this function one here, we need a return type. Okay, that is the difference. I think what we have discussed so far, you have already learned, right? Or is there something new that you haven't seen before beside the global and local variable? Okay, I presume that everyone have already seen this before. Like you have already taken the course for one semester, and you cover on everything like the basic on data structure and programming concept. Okay. But feel free to ask a question while like we are going along the slide. If you have any question, you can push me for a second, and then we can discuss about it. Okay. And we will go next a little bit here. Okay, this is a part of the call where we discuss about the global and local variable. It gives you an insight details on how we differentiate and how it can be used. So in local variable, it's just a kind of variable. When we create it inside a function, okay, the place where we create it is inside the function. Main program here is also a function. If we have created some variable in here inside the main here, this is called local variable. Okay, and when we define our own function, the custom function here, the variable that we create inside this function is also called local variable. Okay, that is the term. And for the global variables, variable that are created outside the function, but it should be below library. For example, where we include our library here, we put our global variable down below that. It can also below other function like sum here. We can also do that, but it's related to the scope. If we put it somewhere, for example, the rule of thumb is that you can recognize some function or variable only if that variable or function created after before already. For example, at line 6 here, you can call to this two variable because it's already created before, because in the program when it compile from line 1, line 2, line 3, line 4. Okay, so when it is compiling line 6 or line 7, it know, okay, what is line 3 and line 4 already. Okay. And some more information about global and local variable is that for local variable, when the function finishes executing, all variable in local are destroyed. It means it will be deleted. You cannot use it. For example, result here, it can only use inside this function. The other function cannot use it. This is called local. Okay. And for the global, it can be used from anywhere, any function, because it is designed as global. It's a universal. Everyone can use it. Okay, that is the main difference. And after we compile and run the program, what we will see here is these the outputs. We will have, as you can see in this example codes in C programming language, we create two global variable. We create one function. What we do is to sum and multiply by certain number. Okay, multiply by 2. And when we call it, okay, this one 2 times 5 is 10. 2 plus 5 is 7. Okay, we plus first 7. 7 multiplied 2 is 14. Okay, so we got 14 here. And next thing is this just the same way we call to the function, right? Just at line 19, what we do here is to display directly inside the print command using this certain format, percentage %d. It is a format for integer number, because this one is returning integer. Okay, so we can also write inside print, or sometimes we want to store it in a variable. We can do it as in line 20 here. It is either way is okay. You can store it in a variable, or you just display it directly. It's fine. And the thing is, we display some global variable here. Like we call this sum function 2 times. Okay, one time here and another time here. And as you see in the logic of this function, what we do is to increment the value of n. And here it starts by n is equal to 0. So this function has been called 2 times. One time, this is second time, right? So it will increment 2 times. So that means we obtain from 0 to 2. So when we display n from here, we got 2 here. Okay. If we don't declare n here as a global variable, for example, if you uncommand, for example, you command this one, you put // 2 times here to command this line. This code cannot find n. Okay, this n is not recognized n because it is inside main, and there is no global variable called n. Okay, even n is inside this function, but in this place, the scope of variable are different. It cannot be used. Okay, if we don't declare it as the global one. Okay. So I think I will not go further detail more on this. We will jump next to the next topic. The main topic is about recursive function actually. But what we have discussed so far is about the review on the function. Okay. So what is recursive? As you take a look on this picture, how do you feel? Like, what is your imagination when we say what is it? And then as you can see in this picture, a woman, okay, taking a look on a TV, for example, and this is how the TV look like. Okay, and then he started to question, like, oh, say, what is it when she's looking at this TV? What is it? because inside the TV you see something like something redundant and repetitive, like the same thing many times, right? And then another guy say, okay, it's a recursion. Okay, that is the idea of how the recursion is about. It's about repetition. Okay, it repeated one inside another. Okay. Okay, we jump straight to the introduction. What is recursion? Okay, the term is like we have recursion, and recursive function. Actually, the term here, when you say recursive and recursion, this is a noun, right? Recursive here is like an adjective or something. This is a function as a noun. Okay, you can say recursion, and you can call a recursive function. Okay, because adjective is standing in front of noun. Recursive function. Okay, we can call the word here. So what is recursion? It is a kind of algorithm, a techniques, a way of doing something which call itself with smaller input value. Okay, so this is a very short but meaningful one. Recursion is somehow we call to itself. For example, the algorithm itself, it repeats the algorithm itself with the input smaller value, because whatever we execute the way, for example, we have a way to calculate something, we pass an input value, right? For example, if I want to sum number from 1 to n, so n here is the input value. If the input value is 5, the summation should be look like 1 plus 2 plus 3 plus 4 and plus 5, and then we give the result. And sometimes the input value here is not 5, some other value. Okay, so in recursive problem, we try to simplify the problem, smaller and smaller by adjusting the input value. The input value here, it can be bigger and bigger or smaller and smaller. The thing is to make it simple. Okay, make it simple and simple, and then one at some certain time the problem will be solved, because the problem is trying to call itself again, but simple and simple than before. Okay. And in programming language, what is recursion? It is ability, a kind of way that we give to the function to call itself. Okay. So as we have discussed on the review on function so far, we have seen that we create a function, we call it inside main program, and then the function execute, and then it finish, right? Actually, the function inside the function itself, it can also call itself. We don't need to call in main, for example, but it must call first from main. But the function itself, it can call itself in the body. Okay, the sound may be confusing, right? We have a function here. For example, I say f1. Okay, f1 is function 1, and this is the body of the function. Okay, and some part of the code you write some logic. For example, you have some conditional statement. If some condition happen, you call to this function. Okay, I say f1 somewhere inside the code. Okay, and maybe I call to the function here, f1 here. So when it reach this line, it will repeat, right? Repeat the code again, because this is the same, like this function call to this function itself. Okay. So I hope you a little bit more clear on this, on how it calls itself, just the way we write codes inside the body of the function. And to write a recursive program, we need some steps. For example, the first one, we find a recursive decomposition of the problem. That means in which case that we should allow our codes to call the function again. Example in here, f1 here, we should not put it directly inside the body. We should have some conditional statement. If something happen, if number is not 0, okay, we call this function again, for example. Okay, that is the case that we need to study, that we need to focusing on and analyze on the problem, how the recursive function should be called. Okay. This is normally it's we say the solution in general. Okay, decomposition of the problem. We try to decompose the problem to smaller and smaller and smaller. And the second one is to find the stop condition. We call it stop condition, or the term is called base case. Base case is a kind of condition that allow us to stop recursive. Okay, we know that recursive it call itself again and again. So we should find the base case when it should not call again. Okay, it will stop there. Okay, when it reach this condition, the function will stop. It not call itself again anymore. Okay, that's the thing that we are focusing on. We may go a little bit more, and then we will see some example, and we will go into coding environment, the tool together. And recursive function, actually this is just we have seen just like to make it easy to see, we just repeat it again. Recursive function is a function that calls itself repeatedly, like again and again, until certain condition is satisfied. Okay, we try to call the function again, call itself, okay, until the condition appear. Okay, for example, if the number first is 10, and each time we call to this function, we reduce this number 10 here to 9. Okay, for example, minus by 1, decrement the value by 1. So if we call it 10 times, that means that number will reach to 0, right? So the stopping condition can be 0. Okay, if it is 0, stop. Okay, no need to call it again. Otherwise, okay, repeat, call it again, but the number should be minus 1. Okay, this is the component that we call keep a repetition condition. It's like the general case that we decomposition the problem, and we have stopping condition. Okay, we need these two things so that we can define the recursive function. And the one of the remark here that, for example, when you work on loop, there is a case that if you don't define the condition inside the loop properly, your loop may run infinitely, like it's never stops. Okay, it runs again and again and again until you're running out of RAM or running out of battery or some other things, some other events occur in your computer. Okay, that is the case that infinite loop happens. And also for the recursive function, it works the same. If you don't find the base case properly, the base case, it is a stopping condition. If you cannot find that properly, your recursive function still call itself again and again. It will not stop until your program crash or RAM is running out, battery is low or something. Okay, it's work like an infinite loop. Okay. And okay, next we will see an example of the recursion in how we define the factorial number. Okay. I think you have seen this kind of problem before, but we solve it. We find the factorial using what we call is a loop, right? You have for loop, and then you write some code in order to find the factorial number. Okay. So after this, we will go to the code and we will testing. Okay, we try to use for loop, and then next we try with recursive function. Okay. So the idea of the factorial number here, for example, you have a number, say n is a number which is a positive number. To find the factory of this number, there is a formula, something like multiplication, right? The natural number from 1 to this number, you multiply all of them together. This is a way to multiply to find the factorial number. And it can also simplify to a shorter form. It's like if you find n factorial, that means you are trying to find the n minus 1 factorial times n here, right? That is the property of the math formula. It's the same way how we find this thing, okay? And if we reverse it to another form, like it's n factorial is equal to n times n minus 1 times something and 2 2 and 1, for example, all the way to 1 here. It's the same as you write n times n minus 1 factorial, right? So this is kind of factorial recursive function. Like when you try to find n factorial here, the formula is something like you have n minus 1 factorial times n multiplied by n here. So if you take a look on the is this a factorial? Okay. If you take a look on the problem n minus 1, this is also the factorial, right? But the number here is smaller by 1. At first it has n factorial, now it become n minus 1 factorial. So this is called the problem itself again. You can repeat this process using a recursive function. Okay. So this case, subproblem n minus 1 here, it's actually the same form as initial problem, like the starting problem that we seen is n factorial. And when we have the subproblem, the smaller problem is n minus 1. So this is called smaller case. And when we coding, okay, we start to call this process smaller and smaller. When it call 5 times, the number is reduced by 5 already, right? Because minus 1, 5 times, it reduced by 5. And some certain point, it will reach the solution. Okay. So I think I will not go forward a little bit more. We will, before we take a break, okay, we will take a look on practice some coding and how we testing some solution and how to solve this factorial. We use a for loop and also the recursive function. So I will okay. I will share you my code editor. In here I use a code block. Okay, code block here. Let me close this up first. Maybe create a new one. It's okay if you use another tool like II-BOU+. You can open it up and if you can test it all together, it's fine. So I will give it a name first. This is we will find a factorial number using different techniques, like we use a for loop and we have the recursive function. Okay. I think my program is restarted. Let me rerun it again. Okay. So while we're waiting on this, like everyone, like you can open your tool like II-BOU+ here, and we can coding along. The main goal here is to find the factorial number. Okay. Okay, it's still loading. Okay, let's wait for a moment. Okay, it's back. It's back. Okay, if we create a new file and I will save it first. So the best practice, what I normally recommend to my students, when you write your program, first you make sure you save it. Sometimes they just typing, okay, trying to think how to solve the problem, but forgot to save the file. Like sometime later, okay, the file is lost, and then all the work that you have tried is all gone already. Okay. So we test it, factorial number here. We use C++ because we practice with C++ here. So the extension is .cpp. I think everyone already know about this. And the first part is we we write the structure of the C++, right? So there's some library. We have IOStream and we have main function. And right below the library, we have a namespace. Using namespace, okay, space std, okay, it's a standard library. We cannot call to cout or cin if we don't put using namespace, unless we proceeding with the prefix std colon. Okay, so in here we're trying to find the okay, am I right? The problem here, find the factorial of number. Okay, everyone can see my screen, right? I'm not sure whether it's too small in your computer.
Yes,
Can you
Yeah, I can
see it well?
clearly see your
Okay.
presentation. Thank you.
Okay, that's good. So we will try to code to find the factorial number. So the first way is we using one way is using a for loop. Okay, for loop. This is the traditional way that we normally do, right? When we try to do some repetition, we use a loop. Okay, in this case, we can use for loop. The second way is we can use a recursive function. Okay, recursive function. Okay. So we will see the first way first. First way. Okay. So when we try to find the factorial number, for example, let's say the factorial number of number 3, or the number is input by the user. We can say integer n here, and let's say cout and cin. Okay. Do you display a message? Please input a number. Okay. And next we get this input into this variable. Okay, we have cin and cout. I think everyone familiar with this syntax, right? You have been learned C++ already. We have cin and cout in order to get value. What we can do in the tool here is we test it in the command line. Like we run this. There will be a black dialog pop up, and we try to interact with the program by providing some information through the keyword. This is what we can do when we first learn basic concept of programming. Later on, you will apply with the GUI interface and so on. Okay, in here, when we get an input number, and next, what we can do is we try to loop in order to find the summation, the factorial number. Okay, so the rule is factorial number, you multiply 1, 2, 3 until n, right? So you can generate a loop. Let's say a for loop. We start from 1. This is the syntax of loop. Let's say k. Okay, k equals 1. This is starting point. The condition is k less than or equal n. What the n here is the number by the input. Okay, the condition k must less than or equal n. That's the condition. And the increment, okay, the update here, k equal to k plus 1. Okay, I think you may already familiar with this loop syntax for loop. You have the starting point, you have condition, and you have the update. Okay, so each time the loop run, you try to check condition. If condition is still true, okay, the body inside loop still running. Right. So in here, what we do is we try to find the summation, right? What we get from for loop here, we get 1, 2, 3, 4, 5 until k equal to whatever number we input here, right? So what we can do here, we can create let's say f here, referring to the factorial result. So I say f equal to 1, for example. And inside this one, we have can define a formula f equal to f times k. That means when loop run first time, we get f times k, we store it in f. And when we repeat it again, like it's like the number multiplication is keep increasing, right? First we multiply by 2, next we multiply by 3, by 4, by 5, by 6, for example. Okay, the number is keep increasing. Finally, we can display the result here, cout. We say some certain message, factorial of factorial, let's say whatever we input here, this is the symbol factorial of n here equal to something is f here. Okay. We can put a new line. We use the command E and the L. We will go to the new line. Okay. We'll run this first. I think that's it. We can what we can write, and then we will find this number first. Okay, so now the black dialog is pop up, and it asks us to fill some information because we type the command C in, which allows us to input from keyboard. So we type some number. Let's say 4. Okay. So factorial of 4 is 24. Okay, what it does is loop from 1 to 4 and then start to multiply 1 times 2 times 3 times 4. Okay. And as you can see in here, you may find a problem of the domain storage of the integer number. For example, if you provide the number too big, for example, you put 20 or 30, the integer here cannot hold too much number because factorial of 20 or 10, it cannot hold that. Okay, that is related to the data type. You can use other data types like long or some other things. So to make it simply, we just use integer. Okay, but just to make sure you know about this concern, if we put the number is too much, for example, you put 30, and then make sure this number is correct. If you verify it into the number on internet, for example, there is a calculator online, you verify it, because factory of that number is too much, and the integer cannot hold that too much number. For example, you put 100 here, there's a problem like it says 0 because integer cannot hold that too much number. Okay, that's the things related to data type. Okay. Just to make it simple, we use integer here. Okay, so this is one way how we can solve this kind of problem using for loop. So next we will take a look how we can do it using recursive function. Okay, so I will comment this one. Okay, we will not use it. And what we do here, okay, we can okay, just grab this out, and when we define a function instead. Okay, so this is just what we repeat. We create a variable, we have some number here, and we get some input. Okay, next thing, okay, we can define the recursive function. Let's say f equal to find factorial. Okay, this is a function which we will need to create it. Factorial. And then we pass n here. Okay, and then we can see out f. This is the number returning from this function. Okay, so next what we need to do is to define this function. Okay, so I will create this function. The return type should be integer, and this is the name of the function, and we need one parameter. Let's say it's n. Okay, and here can be different from what we say n here, right? Because this is a parameter, a holder, like a representative, like to pass to the function. You can use it any name. You can say m is okay. Okay, no worry. And what we need to do here is we write some logic in order to find the factorial of this kind of problem. So just to remind you, in the recursive, we need stopping condition. Okay, stopping condition, and another thing is keep repetition, right? Keep repetition problem. Okay. Okay. Repetition problem. Okay. Which condition that can be used to stop it? For example, it should be stopped at some point, because in factorial we know that 1 factorial is equal to 1, right? If we find 2 factorial, it means 1 times 2. If we find 3 factorial, 1 times 2 times 3. Okay. So in this case, we know that stopping condition is at 1. So if you say if m, the input is equal to 1, what we need to do is just return the number, say at 1, right? Because 1 factorial meaning 1. Okay. And next, if. Okay. Beside this is kind of keep repetition. If m is not equal to 1, okay. For example, if we pass 4, then it's not 1. What we need to do is return also. We return, and return here is a recursive. Okay. Recursive here. Okay. It means we call this function again. So because this take an integer, we return it, and when we return, we try to decompose the problem into smaller one. So we say factorial here, the name, call to the name, m minus 1. So the parameter is smaller. In the formula of the factorial, like we multiply, right? So we take m here, take m, multiply by this function again. When we call to this function again, the input here is smaller than before. When we pass 4, and then if we reach this one, okay, condition is not correct. So if you take here, what we need to do, 4 times factorial of 3, right? So m minus 1 here is 3. So 4 times 3 factorial. And we will keep repetition this again. When it run again, okay, 3. This one is not right. Okay, this one, 3 times factorial of 2. Okay, so before it also already have 4. So 4 times 3 times 2. Finally, every time multiply by 1. Okay, that's the thing. And I think that is for the recursive problem. This is the main core of the recursive. We multiply it by this number, and with the smaller problem, with the input is smaller. Here's the input of function. It's smaller, we minus 1. So let's check this out. And let's say, okay, we take a mistake here. It should be the same here. Okay, the same mistake. Factorial of this number. Whatever input is something, okay, we call to this function, which we define in our recursive function here. Okay, okay, let's run this. And we will input a certain number, let's say 3. Okay, 3. So factorial of 3 is 6, right? So in here, what it does, it's trying to pass number 3 here into this function. And when it is 3, okay, it is not equal. Okay, so it will come to this L blocks. So we have if and L, right? So we come to L. So in L, take M. So original M here, when input is 3, it's 3 times something factorial of 2, right? So 3 minus 1 is 2. So 3 times factorial of 2. Okay, I will keep repetition this step. Okay, it's smaller and smaller. Maybe we can try one more time or test another number. Let's say 5. Okay, say 5. Okay, so what it's trying to do, 5 times factorial of 4. When it's called to factorial of 4, it's repeat, run again, 4 times factorial of 3, so on and so on. Okay, this is how the recursive function works. Okay. Do you have any questions so far? You can try coding a log to test whether you put it, you can run it the same way. You can understand from that and later on. And if you have question, okay, you can ask. Okay, this is the example of the problem and what we have seen in coding here, like the factorial 4 and return fact of 3 multiply 4. Okay, and then it's trying to recursive to the smaller and smaller, and at some point of time, if you reach factorial of 1, right? Factorial of 1, if we get this number. Okay. And if this lecture note, as you see, like sometime n factorial is 1 when n is 0 or n is 1, right? It is also possible that the input number is 0. 0 factorial is also 1. Okay. So I think I will push, and here we will take a short break. If you have any question before we break, you can ask here or not. You can ask when we are back. It's fine. Okay. So while we're taking a break, I will share you the lecture note somewhere maybe in the chat box. Okay, I will drag and drop it here. Let me drag you a file. Okay. You cannot.
I think you need using cloud services like Google Drive or Dropbox.
Oh,
Yeah.
it cannot drag and drop directly, right?
Yes, in Zoom we can do that.
I see, I see. Okay, so I think I will share you a link so that everyone can download it. I will share you a link. So we will take a short break now, and we will come back at about 10:43. Okay, 10 minutes break.
Okay,
It's fine for everyone,
10:43.
right? We take 10 minutes break. Okay, okay. So we'll take a note here first. Breaks. 10 minutes. 10:43. Okay, we come back at around 10:43. So while we're taking a break, I will share you a link and you can download the lecture note and review it. Okay, hello everyone. I think we are back from the break. Can you hear me well?
Yes, sir.
Yes, I can.
You can hear me well, right? Okay. So we will continue. So I share the lecture note in the chat box. You can download it, and so we will continue next. And if you have any question so far, okay, you can ask. Do not hesitate. And any question you want to ask, you can raise it up. It's fine. Okay, maybe you don't have question now. Maybe we go a little bit more. Actually, there are some more problem than we can coding along together. It's okay. So what we have seen from the previous session before we break, we try to test a program that we can use a recursive function in order that we can calculate, we can find the factorial number of either using a for loop or using a recursive. We can do it the same way. In recursive function, what we need is the base case, the case that it will stop the repetition, and the case that the code will rerun again. Okay. That is 2 points that we are concerning about when we trying to solve a problem using the recursive function. Okay, next we will see another type of problem. We call it sweet Fibonacci. Okay, I think most of you perhaps already have heard about sweet Fibonacci before when we learn mathematics. This is a kind of series sweets. For example, the property of the sweet Fibonacci is that the first what we call the first term, right? Okay, the first term of the sweet. This is starting from 0. When we say U0, okay, U0 equal to 0. This is U0 equal to 0. U1 and U2 equal to 1. Okay, this is the property, right? This is defined by default. U0, U1, and U2. This is the term. Which term it's which position? Okay. And how the sweet Fibonacci work is trying to sum. For example, if you want to find the n term, okay, n term of sweet Fibonacci, you will take the two first term before that term, sum them up together, you will find the term n here. For example, you have 3 and 5 here, 3 and 5. To find the next number of this fit, you just sum them up together, right? Okay, so 3 plus 5 equal to 8. Okay, that is the property of the sweet Fibonacci. And if you want to find the next number, for example, in this case, 13, what we do is we sum the first two number before this number together. 5 plus 8 is 13, right? Okay, that is the property. Like the rule, the characteristic of how the Fibonacci calculate. So in this case, we can conclude that with this condition. Okay, this is the condition. The term of the sweet Fibonacci will equal to certain number. For example, either 0, 1, or sum the first two number together. It depends on the term. For example, which position we are working on. So in this example, as you can see in the pseudocodes example of the recursive function on the right side here, we try to find the n element of the sweet Fibonacci. For example, if I want to know, for example, the 10 element of sweet Fibonacci, what is the number? This is the property, and if we count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 34 or something, right? And the function that we are trying to code, it looks something like this. Where we pass the position, the element, for example, 10, 20, what is the number should be? Okay, it based on this property that we define from this formula. So in here, as you can see in the pseudocode example, I think you have seen the pseudocode before. I'm not sure, quite sure if everyone used to see what is pseudocode. It's just a kind of explanation codes, but it's not written in certain language, not written in language. Just like some format, like you have some keyword, for example, function, begin function, end function, just to tell you, okay, this is a function, this is the start, and this is the end. Maybe you have seen it before. And this function, where is this the name of the function, the parameter it needs, this is the return type. So to my class, as you have seen, like algorithm and programming, normally when we illustrate how certain problems, how we can code something, we put it as an algorithm techniques, like where we write some pseudocode, okay? Just to explain. Based on syntax in C or C++, we can just adapt it using the syntax letter, that's fine. So this is function, we start the function, then we finish the function. And what we do here is we have some conditional statements. We have if, okay, this is then, it's just equivalent to the sign that we use in the C or C++. We open the bracket, right? Then we use then, and then we have end if here. It's okay, this one just a normal written language, no need to concern about the syntax. But what we're trying to explain here, when we take an input number, which is integer, and then we, the goal is to find the element of this with Fibonacci. What is the number? So based on this property, we can transfer it into the form of recursive. When n is equal to 0, okay, you just return 0, and when n is equal to 1 or n is equal to 2, okay, you return another number, which based on the property, it should be 1, right? Because the element, first and second element, it should be 1, okay? And else otherwise, okay, the rest of the condition, if you go to the recursive, okay, this is the recursive part, the main part of the function is recursive. What is recursive is try to sum them up together, right? So we return something here, okay? So after you have seen so far in the function, we have seen a lot of return keyword, right? Sometimes you just don't need to write return, you just print, that's fine. For example, you write a recursive function to display a number, for example, from 1 to 10, okay? Instead of loop, we can try using recursive function. Okay, let's try this out in the our code editor. Okay, we close this up first, then we go to our code editor here. Okay, so we'll create a new file. Fibonacci.cpp. Okay, CPP. So first thing first, we write everything about the structure of the program. We have ISO stream using namespace, std, and we have a main program. Okay. So the goal is to find the sweet Fibonacci, find n term of sweet Fibonacci. Find n, let's say n position, position of sweet Fibonacci. Okay. So in here you can say, let's say we will have a function, and the function, let's say I have an integer, let's say s, we call result equal to sweet Fibonacci. Okay, and if you pass a number, let's say it is 5. Okay, This is a function that we're going to create, and this function should return a number, and then we put in here, and then finally we will display this one. Let's say cout result. Okay. So to define this one, we go out to main. We have integer in the name of the function here, and it take an input parameter. Okay. Let's say n. Okay. So the rule is that the first we check if n is equal to 0. If equal to 0, we return something. Turn 0. Okay. And in case that n is not 0, it is 1 or operator or, we use vertical bar to time here and equal to 2. Okay. Is there next two element after 0, right? The property is 1 1. Okay, so we return 1 here. You see in the property here, the property of the switch Fibonacci. Okay, when n is equal 1 or 2, the number, the switch, it should be 1. Okay, the rest after n equal to more than 3, it should be summation of the property summing together, the preceding two. Okay. And next we say L, we can use L or L if it's fine. Okay, L if n greater or equal than 3, return, and then we type recursive here is called to the name of this function again. Switch Fibonacci of n minus 1 plus switch Fibonacci n minus 2, right? Because the first we are trying to find switch Fibonacci of n. So the rule is if when n is equal more than 3, we need to find the summation of the two preceding number. Okay, this is two preceding number. I say we need to minus, right? Position minus 1 and minus 2. Okay, the first two positions, summing them up together, let's find the next term. Okay. It think that it's for the logic. If that's enough, okay, we can test this out. Okay, 5. Let's see, verify with our property here. Because the position we counted from 0, right? So in here, 0, 1, 2, 3, 4, and 5, we got number 5. If you take a look on the switch Fibonacci here, the term here, 0, 1, 2, 0, 1, 1, 2, 3, 5, 8, 13. When we count it's starting from 0 and equal to 0, right? The position is 0. Like when we learn array, we have the index of the array 0, 1, 2, 3 or something. Okay, so now we got 5. Okay, because we pass it 5. Let's say I put 8. Okay, 8. So 8 is 21. Okay, let's take a look on the property here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 is 21. That's correct. Okay. So I think that's it for the how we can use the switch Fibonacci, use recursive function in order to find the position of the the n term of the number in the position of the switch Fibonacci. Okay, we found what is the position 5, what is the number, and there could be many position, right? If we see a series of switches, example, I count, let's say number 99. What is the number in that position of that switch? Based on the recursive, it will find us the following number based on the summation for us. But just to inform you that recursive with recursive, because it try to call itself again and again, right? So in some problem, it's not recommend to use Fibonacci, because when it trying to call itself too much, the program get crashed and it will stop loading, for example. In this case, it's 99. Okay, probably it's running, recall it again and again, trying to call too many times. So based on some problem, it's compute very fast based on the logic we define. So as you can see in here, it's still loading, right? Because there are too much recursive, like it trying to call again and again. So I'm gonna stop this. Let's try another smaller number. Let's say 30. Okay. But in loop, okay, you can find it very fast. That is cool. In loop, you loop 10,000 times, it will run very fast. But some problem cannot be solved using a for loop. Maybe probably you can, but you need to write like too complicated logic inside the loop. Like you check if, when is the preceding number, when is the second preceding number, sum them up together. That's kind of difficult, like hard way of thinking. Okay, but in the recursive way, it's not much difficult, right? If we understand the property well of this fit Fibonacci we have discussed from the slide, when the position is 0, the number is 0. When the position is 1 or 2, the number should be 1. Okay, we just try to translate those property back into the term that we use in the condition. Okay, that's it. Do you have any questions so far?
No, I don't.
Okay, that's okay. Okay, so we think we will move forward a little bit more. Actually, most of the slide here, like is we practice like coding along together, and there are some questions that I have prepared that you can testing it along when you are at home. Like just try to practice what you learn on Swift Recursive. I think I will not cover more. I think that's all for the recursive. Actually, that's the important. What document actually it's available online. You can explore it more. I think that's the basic one. And just a remark here, when you're talking about the recursive function, as we have discussed, we have what we call base case and keep repetition or something, right? There's the term that we normally use, base case. Okay, base case. It's just like a stopping condition. Okay, when the stop condition, when the function should stop calling itself. Okay, when it should stop, it can. This is called base case. Like we say, normally it returns a constant number. When we know it returns a constant number, it does not need to decompose its problem into smaller one. That is a base case. And when we call recursive, we try to keep repetition condition, right? We just mentioned, keep calling itself, it keep a repetition condition. Okay, repetition, trying to call itself again. What we need to find the condition. Okay, when it will, when it should stop or when it should continue running. Okay, and in the keep repetition condition here, when we try to call after we satisfy with the condition, we will call itself again, right? Call function again. So when we call a function again here, one thing that we keep in mind is trying to make it like we hoping that at some point of time it will reach the base case, which allow the function to be stopped, right? If you try to call a function here again, and then the number still keep go higher and higher, which will be far more than the base case condition, it means that the function that you are trying to coding is like a call an infinite loop, because it's never be a case that it will reach the base case, right? So just keep in mind when you call to recursive, make sure that the parameter that you pass to the function at some point of time it will reach the base case. Okay. I think that's it for the remark here. Okay, we will see a little bit more on how we practice to write some certain problems. Okay, I think we have some time that we can practice on this. So the first one, let's take a look on the first one. I may need a student that you can read this one. Okay, you can just read this one out loud to everyone, and next we recording along together. I will share your screen again. Can anyone read the first practice here, the first exercise here? What we are trying to do. Okay. First thing first, like when we start coding, the first thing that we need to do is to understand the problem, the exercise. Okay, what is the purpose? What is the goal? What they want? What is the output that we need? Okay, after we analyze that, okay, we can start to coding a lot, coding right away based on what input that we need, what is the process that it is required to take, and finally, what is the result that we should output on the screen to the user. Okay. So can anyone read the question one, please? Anyone volunteer? Okay, maybe we may pick someone here. It's okay. Mr. I'm not sure whether Mr. and okay, this one. Mr. Komnang Mengku Widata. Hello. Could you help to read the question one, please?
Maybe could pick the number of our student.
Excuse me?
Our student name, there is a student number there.
Okay.
Yeah,
This is the number is like 2015101019. Okay. The ending is 19.
Okay, it is Igusti Lanang Agung. Sorry, the
91. 19. Okay. The
oh,
ending
sorry,
is
19.
19. Okay.
Komang Mangku.
Could you, are you here? Okay. Could you read the first exercise?
Yeah, could you read the first assignment?
Maybe he has problem with the mic or something. We could not hear you well. Okay, maybe we can go to another one. 29 at the ID is 29 ending 29. Mr. Diva, Kadek Diva. Okay. Hello. Could you hear me? I'm not sure whether my internet is working well.
Maybe some of our students is still afraid using English because it's
Okay.
not our main language.
Okay. That's okay. That's okay.
Yeah, but you don't have to afraid, student. I think it is time to you to practice your English. It is a best
Yes.
time to practice your
Yeah.
English.
Actually, it's the same like when I was a student. I'm so afraid of like asking question, talking to the friends or the teacher. Like it's like what we say is hard to communicate. Like, but after try several times joining presentation, we found myself like get better by day and day, and like it actually it is a practice actually. when we practice more and more, and then we are familiar with it, and we are confident. Like actually, at the first is it kind of butterfly or something. I feel that when my first time of learning, asking question, joining presentation, and so on.
Okay, maybe any volunteer to read the question? Maybe.
Okay, maybe volunteers, but okay.
Okay, I
Sorry,
think
Mister.
Okay,
I
okay,
can
please.
help you, Mister.
Okay, please. You can read number 1. Thank you. Hello.
Hello, Mister. Which one, the girl or the boy?
Okay, maybe the boy first. Okay, we can follow the
Me.
next one. Go to
Okay.
the lady. Okay.
Thank you. Calculate the summation 1 plus 2 plus 3 plus blah 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 till plus n using recursive where n is a number input by a user. Create a recursive function that takes one parameter. In main, get a number from user, then call this function to find summation. Display number from n to 100 using recursive.
Okay.
I make the code right now. Yes or no? Sorry.
I think it is also good if you can share like the code, but it's okay. Like we can coding along together. It's fine. Don't worry.
Okay. I'll
Okay.
make this. I'll try to make this.
Okay. You can share that. Okay. I will following you like any question. I will give you comment on that. So you will share your screen, right?
Can you stop your share screen, Mister?
Oh, okay. I will stop first. Okay, we stop sharing screens. Okay. You can start. Okay, thank you.
Okay, thank you. Wait a minute. Okay.
Actually, this problem is some kind of problem similar to factorial, right? Factorial we multiply, right? So this case we do summation instead. It's kind of similar.
Okay. I'm sorry. Can you see my screen?
Yes. Okay, I can see you well. Okay.
Okay. I have tried to make the function about the summation, and I think it's similar like to the factorial one, but it's just a sum using when factorial using what is called
Summation. Okay, this one is summation.
yeah, this is the summation, not
Yes.
yeah, sorry, my English is so bad.
It's okay. This okay. I think that's well enough. Can understand
Okay.
well.
Now we make the output maybe. Yeah.
Okay, we get the input. So you're trying to display a message first. Okay. We put in and then we get input.
Okay. Um, Bill, Wait, I forget how to code it. Mm, this and try this.
I think in your code, like you are forgetting something like declaring create a variable, let's say s, and you put the name like line 23 here, sum, the variable name sum here. It's
Yeah.
the same as the function. It's not. It should not the name of the function.
Okay. So
Yes, yes. You can create a function. Let's say okay, integer, and you say s result or something. Okay, so that you can take it and store the sum function.
Here, right here, right?
Yes.
Just like this, like
yes.
this.
Yeah, yeah. And you create s somewhere. You forgot to create s.
Oh,
Okay.
okay.
Yeah. Yes. And when you pass at line 24, when you
Yeah.
pass parameter to function here, you pass the variable bill, right? Not integer a, and then at line 24.
Yeah.
Line 24. Okay, it should be bill, right? The variable you pass to the function.
Oh, okay.
Yes. This is
Okay.
great. I think no need integer int here at line 24 because we just pass variable number to it, right? Okay,
Yeah.
you can remove. Yeah, that's it.
Okay. And now can be.
Okay, you can print finally. Okay.
I'm sorry, I'm new in coding like this.
It's okay, no worries. Okay.
Okay, the summation, what it's called.
The summation. Okay, summation is something. Okay.
Of, of
I think we don't need the sign and here. You don't need and here at line 26. The variable bill and s. You don't need and the symbol and just
Oh.
variable is okay. Okay. Yes. Yes.
Okay, let's try to compile and.
Okay, let's compile it. Can give it a name.
Okay. Oh, okay.
Semicolon. Okay, semicolon. Missing semicolon.
Okay, put the number 5.
Okay, let's say 5. So 1 plus 2 plus 3 plus 4 and plus 5, we got 15. Okay, that's correct. Okay, that's correct.
Okay.
Okay.
Let's try another number. Let's try another number.
Okay, let's try another number. Let's say 9. Okay, let's say 9.
9. Okay.
9. Okay, yes.
45.
9 is 45. Okay, that's correct. That's correct. Okay, thank you. So
Thank
I
you.
think as I recognize in here, like you use C++, right? .cpp. I mean the extension file .cpp. But the way you write is a syntax of C, right? You have print, you have scan.
Yeah.
It kind of a C syntax because C++ is extension of C. That means everything C have, C++ can write it. Just the form you write because you include a C schedule. Okay, that's okay. Okay, thank you.
Okay, thank you, Mr.
Okay.
I go to stop the share screen now.
Okay, you can stop it. I will share
Thank
that.
you.
Thank you. Okay, well done. Thank you. And okay, I will share my screen back. Okay. Can you see my screen here?
Yes, sir.
Okay. Thank you, your friend that help coding one of this. Okay, next, the first one, like you seen here, the first one, summation exactly similar to the factorial, similar case. Just you identify when it will stop, okay, when it reach number one here. We try to sum one to see until n, right? We pass n, okay. And then recursive trying to minus n minus one, okay. And along the way, you can also display some certain message. Now we can see here, like we calculate something and we return, right? Beside the return, we can also display also, it's fine, okay. We can also calculate and return also, that they calculate and display also, it's fine. So if you take a look on exercise number 2 here, we're trying to display, it's because we almost running out of time. I think we'll go a little bit more fast on this, so we can solve this number 2 here. Maybe another student, like I forgot, okay, a girl, right? You can try to read this and we can solve it. Are you here? You still here? You just read it, okay. I will share screen and coding along with you. Okay, that's okay. Maybe. Okay, yeah.
I will
You
read
okay?
the
You can. Okay, please. Okay, you can read number 2.
Number 2. Display number from n to 100 using a recursive function, where n is parameter of this function.
Okay, that's okay. Okay, thank you. I think I will share you my screen and we can go and solve this one. So the goal here is we're trying to display a number from n to 100. If I input the n is 5, what we want is 5, 6, 7, 8 until 100, right? And 5 here is the parameter in the function. So this kind of problem, we can actually, it can be easily solved by loop, right? In here we practice to solve the with the recursive. So we create a new file. Let's say sum.cpp here, and then we structure in and we use the syntax of C++. Maybe if you are not familiar, actually, the thing is like we include different library and then we use the command cin and cout. That's the difference. But it's not quite much different. Include we call as IO stream. Okay, that's the library in C++. We use using namespace std, and we have the main function. Okay. And inside this main function, we can use cin and cout. Okay, so I will say cout, enter a number, and then to get the get number, I can declare a variable, say n, and then to get this number in C, we use scanf. Okay, scanf, and then we need to provide some format, %i, %d, %f, %c, or %s. There are many formats, right, that we need to remember. But in C++, it's simplified way. We can just use command cin, C, and then you type cin here. And then you have the symbol greater 2 times, and then you pass the variable name. That's it. It's very short, right? It's more simple way in C++ language. So next we call the function, okay, display number, for example. So we say display number from n to 100, right? Okay. Number is say n here, the function, and then we create a function using recursive to display this number. So because it did not return a type, we just say void, void, and later we can modify it if we want to get the summation result. Okay. So I say display number, and then we need a parameter. Let's say m. You can also use n. It's okay. It's the same as this one. Just okay. Both ways is fine. And
Hello, Mr. Channa. I think the screen are frozen.
Hello everyone. Hello. So sorry, I was in problem internet connection and it was cut off and just read it back. Can you hear me?
Yes, I can, Mr.
Yes, sir.
Yes,
Oh,
sir.
okay, good. Okay, sorry. And we will finish up what is remaining. So just now we are talking about we are testing on problem number 2, display number from n to 100 using recursive function. Okay, we'll finish this up. Okay, just now we get some number, enter a number, and then we get a number using cn, and then call to this function. So what this function does, we will check if this number is less than 100. Okay, we just display, right? Display it out. Let's say display a variable m here. Then we have a space to make it easier to read. And next, what we do is like if this number is less than or equal 100, we display and then we call it again, right? Okay, we just call it again. When we call it again, this number should be increasing, right? Because, for example, if I say 5, and then the number is giving should be 5, should be display 5, 6, 7, 8, 9, 10 until 100. Okay, so there will be a case that this number will reaching 100. It keep increasing by 1 when you call it 1. When you recursive it start calling this number increasing, right? So there will be a time that if you reach more than 100, when it reach more than 100, this function is empty, right? Because it's not satisfied condition. If you not call again, that will stop. Okay, so you can just simply put that. That's fine. Okay, I will run this one. It's very simple. They say, let's say 90. Okay, so if we display 90, 91, 92, 93, 45 until 100, right? Because when it is reaching 100, and then we line number 8, we display a number, we call it again, and then plus 1. So 100 plus 1 is 101. Okay, and when this function run again, the condition at line number 6 here will not be okay, right? Because the condition is false. Okay, if it is false, this code will not run. That's it. Okay, and if you want to say something like, okay, we say L, if here we want to say, for example, a goodbye message in this when it reach 100, you can just say play L if here, L if M is more than 100. Okay, it's starting from 100, or you can just put L, that's fine, the same way. Okay, and then we just say, oh, thank you for joining. Okay, that is done for this question. Okay, we just give a message when it reach a certain condition. Okay. We don't need to recall it again. So I just say number 3. Okay, and we are trying to display a number for us starting from 3. Okay, when call to this one, 3, 4, 5, 6, 7 until what? 900. Okay, and when it reach 900, it call again at line 8 plus 1 is 901. So this is a condition if we are not true, and then if we come this one, so we see out. So if we take a look the difference between this kind of program to the another like Fibonacci or something, we always see return, right? Return. Okay, so just to be remember here, we don't always need that return and recall this function again. It based on our rule, our condition, our logic. Okay, so in this case, we just put recursive inside this one when is less than 100. Otherwise, we just say some message, and that's the finish of the function. Okay, I think I will not go further on this. If you have, we will have a question. If you have any question, you can take this chance to ask. And in the slide, as I have shared you, there are other problems that you can practice more at home. When you have time, you can revise the lecture again and try to test it to better understand about this. The kind of problem is recursive. It's very confusing, but it may need you some time to practice again and again, and you will get get used to it. And there are a bunch of questions here. You can try using a recursive one. At the end here, do you have any question? You can raise up here before we finish the session here. Hello. Okay, I think maybe they don't have question yet. If we see each other in the next session, okay, you can raise up any question if you have. We can like just review what we have learned, and then we take some time to clarify what your question again. It's okay. It's all fine. Okay, I think that's it from my side. Thank you, everyone. And Mr. Yudi, do you have something else here? I think that's it for my side. Thank you.
Thank you very much, Mr. Channa. I think we are finishing the session this week, and we will be meeting again for the next week.
Yes. Okay.
Okay. I think thank you very much for Mr. Channa for joining for our class, and I will join your class at 2 p.m. here. Thank you.
Yes, yeah. I will also join with you like for the first session. Like I will introduce them to you, and then I will let you handle the class. Okay.
Okay. Thank you very much.
Okay. Thank you everyone for joining, and we'll see you again next week.
Thank you, sir.
Okay.
Thank
See
you,
you in
sir.
future.
Thank you, sir.
Thank you very much, sir.
Thank
Okay, thank
You,
you.
sir.
Thank you, sir.
Thank you, sir.